VPN mode, which means we are launching up a layer 3 interface and not a layer 2 interface. We are using input and output interface again, which is my bridging interface. We get some incoming and outgoing labels, which are 19 and 70 in this case. And to actually communicate with the next hop inside the MPLS cloud, you also need the Ethernet addresses of the next hop, and you need the Ethernet address of the next hop in the other direction, because you need to separate the answering traffic. Okay, so once I started this tool, it just launches up a virtual interface. In this case, oh, sorry. I think I must have one running in the background, yes. Okay, so we got a new tunnel interface, which is TUN 0 in this case, and this enables us to insert traffic into an MPLS VPN. So the next thing I do, I'm just assigning an IP address to this interface. I'm setting the MTU because there is some MPLS label attached to the network traffic, so we can't use the full Ethernet MTU. After that, I will add some routing information to my local machine, that traffic to the other side. Remember, this is the network where Roger's notebook is located in. So I need to add a route that all traffic to this network is inserted into the tunnel. And after I set it up the tunnel interface, which is this one, I'm able to actually ping the other side of the MPLS VPN. So this means I'm not owning an own MPLS VPN, I'm just sitting somewhere inside the MPLS cloud and injecting traffic into some customer VPN. Now I got the choice. Do I want to take part with the IBM VPN, or do I want to take part with the Cisco VPN or whatever? So just imagine, there are some really big companies using these technologies to connect some sites together, and we're just sitting here inside the core and got access to all these VPNs. And as you see, we can use standard tools within this MPLS-enabled network stack.
Yes, and again, the redirection of the MPLS labels was only sitting on the network and waiting for traffic, and now we are able to inject some traffic into this network.
Well, let's see. Just run some Nmap instances, and okay, you see, it's Mac OS, so it can't be my notebook. Okay, let's switch back.
Okay, what are the mitigating controls? A lot of people ask us, okay, what can we do? If you showed us this funky, pretty cool tricks, what can we do? The simple answer is trust your carrier. If you can trust your carrier, you do not have a problem with all this, because you can say, okay, if my information comes over the network of the carrier, someone has to be first to make sure that there is no possibility to attack the network. So you can say to the customer, we need some contractual controls in it. Make sure that everything is secure. If not, if there is something happened, you have to pay us a defined amount of money because of this attacking information. Another thing is you can authenticate everything, but this maybe breaks the trust model. The trust model was everything inside the MPLS is secure. That's what the provider tells us. Now we have seen it's not so secure maybe. if an attacker have access to the core or is inside of the MPLS network. And this again breaks the approach of the trusted networks. Another thing is that you can use some borders of trust, again, use some layer 3 devices for encrypting all the traffic, but the network administrators will say, oh, we are implemented MPLS to throw these VPN devices which are doing IPsec or something else, to throw it away. Now you're saying we are using MPLS and we have to use some encryption inside the MPLS. That's too expensive. So you have to choose your own mitigating control. And yeah.
If you think it's secure enough, you're fine. We're fine too.
It depends on your risk analysis. The third part of the presentation is about carrier Ethernet and the definition of carrier Ethernet. Carrier Ethernet means that some Ethernet frames are transported across the carrier, mostly one carrier. Sometimes a lot of carriers are cooperating, but you can transport your Ethernet frames from one point of the MPLS to another point of the MPLS. So Ethernet is not only used as an access medium, it's used as a service, and these services are somehow depending on the provider or the implementation, called Metro Ethernet or Ethernet over MPLS or virtual Ethernet frames. You can use some layer 2 tunneling protocol version 3. So all this kind of technologies are used for carrier Ethernet. And a simple example for carrier Ethernet is at one side you have some enterprise LAN, and here is also an enterprise LAN, and it's all one Ethernet segment where all the frames are crossing over the MPLS network.
So the red data path could be seen as just a virtual circuit.
Yes. And the most important thing about this is the change of the trust model. In the past, you have two zones of trust. The layer 3 device is the border where your trust zone ends. So Ethernet frames from customer A will never reach the trust zone of customer B. So they are separated. You have a clear instant of your frames. And if you're using this carrier Ethernet, your zone of trust implements now that there's another zone, the carrier zone. So you have to trust the carrier that he uses and provides the Ethernet frames correctly and secure. So the layer 3 devices, are now exchanged through layer 2 devices. It's all one zone of trust. And that means that there's new threats are evolving and have a new scope. Ethernet-based attacks are maybe performed over the MPLS cloud. So an attacker sits in one location at the MPLS cloud, and the target is located on another side of the access MPLS cloud. So you can do some up-spoofing. Or what if you have some different configuration of VTP and you plug in some old switch or some switch with some VTP configuration, and this switch is reconfiguring every switch in all the MPLS network. Or if you have some network protocols like spanning tree, which is designed in the 80s, which was not designed for such complex communication over the MPLS. If you have a spanning tree root bridge, at one side, all the information may flow over the whole MPLS network to another side. So segregation of the networks is not anymore possible. You have one whole